My dear students, welcome to my channel. In the last class, we have to discuss the applications of differential equation for orthogonal trajectories. In this class, we have to continue this series. We have to discuss about laws of growth and decay, right? So, basically, when you have to solve the problems of growth of populations, or you have to deal with radioactivity disintegration, this type of problems, you have to use growth and decay model, right? So let us understand what is laws of growth and decay. So basically, the rate at which the substance changes is proportional to the quantity of substance changes present at that time. So that means you have to make it a differential equation. This simply dx by dt is equal to kx. So what is x? So simply x is the quantity of substance. X is the quantity of substance present at any time. Okay, and t is the time, and k is the proportionality constant. Okay, so if you have, it is for growth, it is for growth. Okay, if it will be decay, then dx by dt is what? This is minus kx. Okay, so let us solve this differential equation. What is its solution? Simply dx equal to dx by x k dt. So taking integration on both the side, ln x is equal to kt plus ln c. So this is ln x minus ln c is equal to kt. So simply ln x by c is equal to kt. So this is x by c is equal to e to the power kt, and x is c e to the power kt, right? So now if you have to solve this equation, you get x equal to c e to the power minus kt, right? So if you have to solve this equation, you get x equal to c e to the power kt. This equation, x equal to c e to the power minus kt. Simple, right? So it is for growth, it is for decay. It is for growth models, it is for decay models, right? So when you have to solve for growth models, you have to use this formula. When you have to solve decay models, then you have to use this formula. Okay, so let us take some problems and we have to understand what how you have to use the growth and decay models, right? So take some examples.
Let us solve the problem. The table shows that the rabbit population on a certain Iceland where X is the number of years beginning with the years 2000. In the first bit, we have to determine the relative growth rate. In the second bit, write a general equation for the population P of t. And third step, estimate the population in 2010. And the fourth step, how many years will it take for the population will be double, and the data will be given in the table that in 2000 it will be 1500, in 2001 it will be 1577, in 2002 it will be 1658, and 2003 it will be 1743, in 2004 it will be 1832, and 2005 it will be 1962. Okay, let us see the solution of the given problem. So first of all, we have to solve the second bit, and then we have to go to the further. That means you have to find out the general solution. So let us see the solution of the given problem. So here, first of all, p of 0 is what? P of 0 is 1500, right? As it is a growth model, since it is a growth model, we have to write down the equation, that is uh, dp by dt is equal to kp. So now we have to just see the solution of the given problem. So as you know that it is a simple variable separable problem, growth model. So the solution is p equal to c into e to the power kt. Okay, so as we know that the initial value is, when at t equal to 0, its initial value is 1500. Just put it here, So 1500 is equal to c e to the power k into 0, right? So when t equal to 0, so the value of p is 1500. Okay, so now we have to find out the value of c. So k into 0, so it will be become c is equal to 1500. Okay, now we have to put the value of c in the given equation, and you have to find out the general solution. So look at the second bit. So the general equation for the population p of t is what? For the population p of t is c, it means c means 1500, so 1500 e to the power kt. Okay, now we have to find out the relative growth rate, so that is the value of k. So our second bit is completed. Now we have to find out the first bit. So for finding the value of k, we have to see a data here that in 2001 it will be 1577. So we have to use this data because after 1 year it will be become 1577. So now when t equal to 1, it will be 1577. That means p is 1577. So 1577 is 1500 e to the power kt. So k is means t is 1, so that's why you have to put the value of t is 1. So let's solve the problem. So 1 by 1577 divided by 1500 equal to e to the power k. So just to find out the value of k, so you have to take log on both the sides. So that means log is equal to what? So k is log of 1577 divided by 1500. So k is 1577 divided by 1500. So it will be some value that is 1.05133 and like that. So that is that is e to the power k. So that is ln of 150033 equal to k. So k is something about implies k is 1 point I think 0.05. So I have to calculate the value of k, and it will be, so I have to just calculate here. Look at here. So the solution is 0.05. So now we have to find out the value of k, that it means we have to determine the relative growth rate. So our first two bits will be completed. Now you have to see the third and the fourth steps, that is estimate the population in 2010 and how many how many years it will be double, population size will be double. So but just put the value of k here in the general equation, in the particular solution, that is p of t is what? 1500 e to the power k is 0.05 into t. Okay, so let us see the third and fourth bit. Dear students, look at the third bit. So you have to estimate the population in 2010. So that means after 10 years you have to calculate the population size. So here p of 10 is what? So 1500 0.05 into 10. So you have to just put the value of t here. So just it will be 1500 0.5, and if you have to evaluate, you have to just calculate this value. It will be, you have to just put the value of t. So you have to just, I have to calculate here, and the value is the value is 2473. Okay, so now we have to find out the fourth bit. Okay, that means how many years will it take for the population to be double. So that means now on the end in 2000 it will be 1500. So the population will be double. That means p of t is what? P of t will be 3000. So when the value will be 3000, right? So initial value is 1500, so that's why the final, that means double means 3000. So p of in place of p of t, just put 3000. So 1500 into e to the power 0.05. So now we have to just calculate the t here. It will be simple. That means so e to the power 0.05 is what, 3000 by 1500 equal to e to the power 0.05 into t. So it will be 2 e to the power 0.05 into t. So t is what, log 2 by 0. Ln 2. So t is what, ln 2 by 0.05. So just you have to calculate this value, so you get the solution. So it will be 13 point something, so that means it will be 14 years. So after 14 years the size of the population will be doubled. Okay, I think you have to understand the given problem. So let us see some
Dear
new
students,
problems.
look at the problem. If the population of a country double in 50 years, in how many years will it triple? Assume that the rate of increase is proportional to the number of inhabitants. Okay. So this is a very interesting problem, and this is a simple growth model like before. So look at the solution. So I have to take that P is the original population. So when it t equal to 0, it will be P. So and y, t is the time, and y is the population at year at after t years, population after t years. Okay. Since it is a growth model, so we have to find out the differential equation. As you know that there is a form of variable separable equation. So here very interesting that the rate of increase in population is proportional to the population size. The rate of increase of population is proportional to the population size. uh, Population size, right? So that the equation will become, so that the equation is what, so that the equation is what, so that the equation is dy by dt is equal to ky. As it is a variable separable equation, that we want to know the solution. The solution is what? The solution is y equal to c into e to the power kt. Okay. For the solving this problem, first of all you have to find out the value of c. So that means at original, that means when t equal to 0, the population size will be p. So from this data we can easily find out the value of c, the value of the constant, right? So look at here. So y is equal to c to the power kt. So put it here, p is equal to c into e to the power k into 0. Okay, so that means c is equal to p. Now look at the given problem that there will be data here. That means the population of a country will be double in 50 years, then how many will it be triple? Okay, so the general solution here is y equal to p to the power kt. So look at the data. If the population of a country double in 50 years,
Means when t is equal to 50, so what will the value of p y, that means y is equal to 2p. So 2p is what, p into e to the power kt, k into t, and t, the value of t is 50. So that is 2 is equal to p into okay, p is cancelled, so e to the power 50k. So ln 2 is equal to 50k. So the value of k is what, k is ln 2 by 50. So now we have to get the value of k. So okay, so after that value of k, so we have to find out the rate of the that means in how many years we need triple. Okay, so that means repeat 3 times to the original problem. Okay, so let us see this one. Look at you. So look at you now. So when we have to find out the time, so you have to find t. So when the original, that means y is equal to 3p. Okay, so put it here. So in place of y you have to put in place of y is 3p, and just write down the equations, and the value of k is ln 2 by 50, okay, into t. So value of p and t, value of y and k, you have to put it here. So 3p is equal to e to the power ln 2 by 50 into t. So now 3 is equal to e to the power ln 2 by 50 into t. So we have to just find out the value of t. So ln 3 is equal to ln 3 is equal to ln 2 by 50k into t. So t is 50 ln 3 by ln 2 is equal to t, and this will be the years that when the population will be increased to its 3 times. So just calculate on your calculator, you get the value of t. So it is uh, approximately years. I think it will be, it will be 79 something, so it is 80 years. Okay, I hope you have to understand the problem. uh, there is nothing to worry about this problem, so hope you all understand this one, the concept of the problem. Okay, so now we have to see so another problem. Okay,
Look at the problem. Let us see this problem. This is a case of decay model. So look at the problem here. The rate at which the ice melts is proportional to the amount at the instant. Find the amount of ice left after 2 years if half the quantity melts in 30 minutes. Okay, so let uh, m be the m be the quantity of ice at any time t, at any time t. So that means dm by dt is minus km. So simply dm by m is equal to minus k dt. So taking integration on both the sides, this is ln m as kt plus ln c. So that means simply this is ln m minus ln c is equal to minus kt. So this is ln m by c equal to minus kt. So you get m equal to c e to the power minus kt. So this is the solution, right?
now look at the problem, that here is a data that uh, half of the quantity melts in 30 minutes. Okay, before using this data, first of all you have to find out the value of c. So okay, let us take our initial quantity small m will be capital M when t equal to 0. That at the initial time our value will be small m is capital M. Okay, so now here small m is equal to c into e to the power k into 0, it is for minus k into 0. So that's why c is my capital M. Okay, so now the solution is, the general solution is, or you can say the particular solution is, small m is equal to capital M into e to the power minus k into t. Now we have to use the initial conditions that when t equal to 30 minutes our mass will be reduced to m by m by 2. Small m is m capital M by 2. Okay, so now you have to use that m by 2 is m into e to the power minus k into t. Okay, okay, the time will be 30 minutes, right? So so 30 is 30 minutes, right? So we have to now we have to solve this problem. So capital M is cancelled out, and you have to take e2 on the sides, and it will be ln half, and it will be minus k into 30. So now let us solve to find out the value of k. So this will be ln 1 minus ln 2 minus k into 30. So that's why ln 1 is 0 and minus ln 2 is equal to minus k into 30. So minus minus cancel out. So k is ln 2 by 30. So that's the value of k. Okay, that's the constant. So you have to find out the value of k. Now just put it in the general solution. Then after that you have to solve the problem. Okay, let us see. Dear students, now when t is 120 minutes, so you have to find out the value of this mass. Okay, so because the question will find the amount of ice left after 2 hours. Okay, so now I have to find out the value of capital M. So our answer will be that small m is capital M into e to the power minus k into t. So you have to put all the values, that small m into k into the value of k will be ln minus ln 2 by 30, sorry, okay, minus kt, so that's why this is minus ln 2 by 30 into 120. So this will be m into e to the power, I have to just use the concepts that 120 by 30 is 4, so minus 4 into ln 2, and we know that elon is 1, so I have to use this one, so e to the power ln 2 to the power minus 4, and this will be upper side, and elon is 1, so that's a m into 2 to the power minus 4, that is m by 16. So our small m is capital M by 16. That means after 2 hours the amount will be reduced to its 16 times to its original value, right? So the amount will be left uh, to its original value. Okay, I hope you have to understand all the concepts. Thank you to all of you. See you in next class.